Welcome to ClickMyProject.com. Let me discuss about the project Energy Efficient Clustering Protocol for Large Scale Sensor Networks. Let me discuss about the abstract of the project, the appropriate minimization of nodes, energy consumption as well as the uniform energy depletion of all nodes are critical parameters in order to increase the time the network is fully operational. Main reason of energy depletion concerns the need for transmitting the sensed data from the sensor nodes to remote sinks. These data are typically relayed using ad hoc multi-hop routes in the WSN. A side effect of this approach is that the SNS is located closer to the sink, heavily used to relay data from all network nodes. Hence, their energy is consumed faster, leading to a non-uniform depletion of energy in the WSN. Because of more data collection and more packet transmission, the usage of energy of the system is more. For performing best clustering process, fan-shaped clustering, where the large-scale network partition into fan-shaped clusters. In this approach, performed with various combination of energy-saving methods such as selection of cluster head and relay node, implementation of relay clustering, and an efficient routing method and hotspot solution. For reducing signaling cost, localization reclustering process performed. Selection of CH. Initially, central area has been introduced. Usage of CH selection can optimize the intra-communication cost and reduce reclustering frequency. Every CH passes the packet to the relay node, and then relay node transfer the packets to the next inner cluster group. All these possible enable the network to achieve good performance. Let me discuss about the flow diagram for our process. Initially, the network model has been designed based on the concentric layer with equal thickness and cluster formation with equal size. In this network model, one stationary sink and is centered at the network model, which has sufficient power supply. Multiple stationary ordinary nodes are located in the network model, which is powered by batteries with limited energy. Node in this model has uniform initial energy and maximal transmission range. Next, in the cluster formation, here proposed fan-shaped clustering algorithm, where network is to partition this large scale network into fan-shaped clusters. Then based on this clustering, we design mechanism including cluster head selection, cluster repartitioning and routing to achieve network lifetime maximization. Cluster formation algorithm use the same simulated annealing to minimize the energy consumption for cluster nodes. When transmitting data to the cluster head, randomly choose a node among the eligible nodes to become cluster head, but also make sure that the nodes are separated with a minimum separation distance from the other cluster head nodes. Next, we have to estimate the central area location where we going to locate the cluster head. So cluster head selection. In the cluster head selection part, cluster heads are randomly chosen from a list of eligible nodes. To decide which nodes that is eligible, the average energy of the remaining nodes in the network is calculated. In order to spread the load evenly, only nodes with energy above the average energy are eligible. The leader nodes in the clusters in some proposed algorithm can be pre-assigned. Cases, however, the cluster heads are picked from the deployed set of nodes either in a probabilistic or completely random way, or based on other more specific criteria based on the residual energy and connectivity, etc. If sensor located around central area, select that node as cluster head, otherwise performing reclustering process. Next, after performing the cluster head selection, we are going to perform the relay selection. Among the cluster member node, any one node taken as a relay node. Next, if once the relay got selected, we have to perform the routing process. Routing is the process of selecting best paths in a network. In the past, the term routing also means forwarding network traffic among networks. The later function is better described as forwarding. Routing is performed networks including telephone network. If cluster head or relay present in next lower layer, then the data forward to next lower layer, otherwise the data forward to adjacent layer. Next, finally, the performance of analyze the performance of FS's basic behavior based on the number of alive nodes, total residual energy, packet collection rate. Comparison of performance with the existing methods such as head protocol. Let me discuss about the ending procedure for our process. Select the main.temp file in the correct folder, click the fill and run for executing this process. This is the main window of our energy efficient clustering protocol for large scale sensor networks. By clicking the sync deployment button, we can locate the sync node, and this is the network diameter, number of nodes are going to be located, transmission radius, node initial energy, packet length, and energy threshold for cluster head and relay selections. By pressing the sensor deployment button, we have to perform the network model where the sensors are located, and by pressing the fan shaped clustering, we cluster the network based on the cluster width, and this is the minimum expected distance for central area where we have to place the cluster head, and the number of clusters in fourth layer. In the first layer, 4 cluster formations are performed. The second layer 12, third layer 20, and fourth layer 28 clusters are formed. And by pressing the cluster head selection button, we can perform the cluster head selection. Here the yellow color node represents the cluster head selections, and here we have to select any one layer for transmitting packet, and here select any layer among 4 for transmitting packet. Pressing the after enter the layer number, to press the enter button, and now by pressing the routing process button, you can perform the routing process from the 4th layer to the sync. This is the routing process via cluster head, and here the cluster head location while transmitting through sync, and by pressing the performance analysis button, you can perform the analysis graph. This will take some time for executing. After performing performance analysis, here we obtain the alive node location, residual node energy, packet collection rate for various node number. Here we have to obtain the graph by pressing the FS's basic behavior. Select FS's behavior. Here we have to calculate various graph. Pressing the number of alive nodes, we obtain the graph. Analyze the number of alive nodes, and by pressing the total residual energy, we got the graph like this. Pressing the packet collection rate, we got the packet collection rates for various time, and selecting the packet collection rate versus central area radius. Pressing the packet collection versus central area radius, we got the result like this. Packet collection rate for various central area radius, and threshold for CH and realization. By selecting the threshold for CH and realization, we have to calculate the first node depth, and threshold for packet collection rate, and by pressing the basic comparison between FSC and head. Here the number of alive nodes between head and FSC graph, total residual nodes, and packet collection rate. This packet collection rate, and the packet collection rate versus time interval, for heat protocol alone, and number of alive nodes, total energy, residual energy, and packet collection rate, no number. Versus various radius of circle area, number of alive nodes, and total residual energy for various radius of circle area, packet collection rate, various radius of circle area. Here we performing the hybrid clustering and routing protocol using fan shaped clustering. Here we obtain the graph between number of alive nodes, total residual energy, and also packet collection rate for heat and FSM. Thank you.